Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our maths and content, and we're going to go through some more questions associated with substitution. So with that, let's get started. Okay, so here we are. So I just put substitution, or this is just the method of substitution. Okay, what we're going to do is just a few questions here. Let's start off with this one. So I have y equals 3x minus 4. This is the first equation. The second equation is x plus y equals to 8. Okay, so we're going to do like a really simple question here. And I always make sure I label, okay, my two equations like this. And what we're going to do, let's put like kind of like an equal sign here. Okay, and I notice, first thing I'm going to do is look at the two equations. Okay, and make sure that one of them is actually isolated for the variable. So in this case, if you look at equation 1, I notice it's isolated for y because y equals 3x minus 4. Okay, so what I want to do is I'm going to substitute, let's put equation 1, okay, into equation 2. Okay, everyone sees that? So instead of this y, I actually just want to put in 3x minus 4. Okay, let's rewrite the equation 2. It's x plus y equals 8, okay? And now we're going to substitute our y value. So it's going to be x plus, let's put in brackets, 3x minus 4 equals to 8. Okay, everyone see that? So it's basically just instead of this y, I'm just substituting the 3x minus 4. Okay, and now I can just put my like terms together. So I'm going to do x plus 3x, so 4x minus 4 equals to 8. Okay, and then we're going to take this negative 4 to the other side, and it's going to become positive. So 4x equals 8 plus 4, okay, which is equal to 12. So we'll do 4x equals 12. Okay, and then you're going to divide it by 4 on both sides. So this 4 cancels out. So x is equal to 12 divided by 4. X is equal to 3. And let's box our answer here. Okay, so just like this. Okay, in the second step, what I want to do is basically sub it back into this equation here. So I see that x is equal to 3. What I want to sub it into is this first equation, okay? Because I notice it's already isolated for y. So we're going to do 3 times 3 minus 4 for y. Okay, so y here is equal to 9 minus 4. So y is equal to 5. Okay, always box your answers. Okay, so I notice now I have my x and y values, and therefore this is the point of intersection. X is 3, and I notice that y is 5. Okay, what I want to do actually, because this is a system of equations, okay, just to kind of see if you have the right answer, okay, I want to make sure I do a quick check here, okay? So let's put check. Okay, so this is my point of intersection with x and y. I'm going to substitute it into both of my equations. So let's start off with equation 1 here. I'm going to put 1. So it's 3x minus 4. The y value is 5. And the x value is 3. So I'm just substituting it inside here. So 5 equals 3 times 3, so 9 minus 4, which is also 5. So 5 equals 5. So we'll put a check mark there. So again, just because it satisfies the first equation does not mean I have the correct answer. What I have to do is sub it into my second equation. So let's write it here. X plus y equals to 8. So I can see this is a simple equation. The x is 3 and the y is 5. So I'm doing 3 plus 5, which is equal to 8. So 8 is equal to 8. Does everyone see that? So now I can say with 100% certainty that I have the right answer for the point of intersection. Okay? And even if you were to use the graphing method and you graph out the two equations, okay, the point of intersection should be 3 and 5. Okay? Both of these values are positive. Okay, are there any questions there? Okay, good. Let's try maybe another example here. Okay, let's try it on the bottom. Okay, so let's try an example where I have the x value here. So it looks like in this example, the x value is isolated. So negative 4y plus 5. Okay, this is the first equation. Okay, and the second equation is given as x plus 2y equals 7. Okay, so these are my two equations that are given. Okay, so what I want to do, again, let's just put an equal sign here. All right, so I notice here that in equation 1, it's already isolated for x. Okay, so we're going to let's do equation 1 into equation 2. Okay, so one more time, I'm just going to write the equation 2 right here. Okay, and this time we're substituting x here. Okay, so x equals to negative 4 plus 5. Oh, negative 4y, okay, plus 5. And keep everything else the same, okay? Does everyone see that? All we're doing is just substituting my equation 1, which is in terms of x, into equation 2. And I can just put the like terms together here. So I'm doing negative 4y plus 2y. Negative 2y, okay, plus 5 equals 7. Just like that. We're going to take the 5 to the other side and subtract it. So negative 2y, okay, is equal to 2. Okay, so it's going to be minus 5 on this side here. Okay, make sure when you are dividing this, okay, I have to make sure I divide it by negative 2. Okay, the signs are very important. So this negative 2 is going to cancel out here. And I see that y is equal to negative 1. Okay, so you notice it doesn't really matter, okay, if you're solving for x or y. I just have to make sure the answer is correct. Okay. I have my y value, which is negative 1. Okay. And again, I want to just substitute it into this first equation because the x is already isolated. So I don't have to do any extra work here. So 4 times negative 1 plus 5. Okay. And so what we're doing here is going to be, let's put x equals negative 4 times negative 1, positive 4 plus 5. And x is equal to 9. Okay, everyone see that? So again, I have my x value, I have my y values. So I'm going to write my point of intersection. Always write the x value first, so 9. Okay, and negative 1 is the point of intersection. Again, you can make sure you do check your answer, okay? You're just going to, again, substitute it into both of these equations. Okay, and both sides just have to be equal, okay? And that way you know that you have the correct answer. Okay, are there questions for that? No? Okay, so with that, let's try one last example, okay? So I'm just going to remove this. Okay, this time we're going to try this question. Okay, so let's try this. So the first equation is given as x plus 2y equals to 5, okay? And then the second equation is 3x plus 2y equals 6, okay? So most likely your teacher will give you questions, okay, that don't give you a whole number. If you do get a fraction, I want to make sure I leave it as a fraction, okay? And I'm just going to reduce, okay, my answer here. Okay, so I have my two equations. Okay, so what I want to do, again, is the same thing. I'm just going to isolate equation 1. So you notice in this case, okay, I don't have, okay, one of the variables isolated. So let's put isolate equation 1, okay, for x. And I'm only looking for basically the coefficients. Wherever I see a coefficient of 1, okay, that's the equation that I want to make sure I'm isolating, okay? So let's do that. So I have x plus 2y equals 5. Oh, so we'll take the 2y to the other side actually. So x equals 5 minus 2y, okay? So we're just isolating here for x, okay, in our first step. And so because we used equation 1 to isolate, I have to make sure I substitute it into equation 2. So let's write down the steps as we do it, okay? So I'm going to put sub equation 1, okay, into equation 2. Okay, and remember, it doesn't have to be this way, okay? If I did isolate for one of the variables in equation 2, I can substitute that back into equation 1, okay? Just the steps I'm using here is the ones that are simplified for me, so I don't have to do extra work, okay? So we're going to sub it into equation 2 here, okay? And I've isolated here, let's just box that so we can see it. I've isolated for x, okay? So instead of x here, we're going to put 3 times 5 minus 2y plus 2y is equal to 6. Everyone see that? We're going to do the distributive property and just open up the brackets here. 3 times 5, 15. 3 times negative 2y, so negative 6y plus 2y equals 6. Okay, remember you could do as many steps as you want here, okay? So we're just putting the like terms together. Take the 15 to the other side, okay? So here I'm left with negative 4y equals to negative 9, okay? So you're doing 6 minus 15 on the other side. Okay, I'm going to divide by negative 4 on both sides. Okay, so I can see that it cancels out. Okay, and what I'm left with is basically 9 over 4. And this is for y. Okay, is everyone good? So I see that it is a fraction. Okay, teachers do not want to see you actually using the decimal values. So we're just going to leave this the same. Okay. And I'm going to write this step actually separately. Okay. Let's write sub back to find, okay, we're looking for the value of x. Okay, and again, what I want to use is just this expression because I already isolated for x here. Okay, so we're going to put x equals 5 minus 2y. Okay, everyone see that? And let's just sub it in here. We're going to sub in the y value. X equals 5. I'm going to put over 1 minus 2 and then 9 over 4. Okay, so I put 5 over 1, okay, because we are going to do a common denominator here. So let me show you one step. Okay, so this is 5 over 1 minus, make sure you're only multiplying the numerators. So 2 times 9, so 18 over 4, okay? Then you're going to times the top and bottom by 4. So this is going to be 20 minus 18, which is equal to 2 over 4. Okay, everyone sees that? Okay, so again, you do have to show your work here. Okay, we're doing a common denominator, just like you adding and subtracting fractions, okay, which is quite simple. And again, because I got 2 over 4, I want to make sure that I simplify my answer to 1 over 2. Okay? And so don't leave your answer as 2 over 4. Teachers will take off half a mark for that. Okay, so with that, let's write our point of intersection because we have both. I see my x value as well as my y value. Okay? So here I'm going to put 1/2 and 9 over 4. Okay, so don't worry again if you are dealing with fractions. I just have to make sure I'm doing some extra steps here like we did right here. And always again indicate what it is you're doing, okay, in the steps just to keep it very clear. All teachers will give, okay, a lot of part marks here as long as you are showing your work, okay? And always remember the first step is always looking at the two equations, okay, in your system of equations and see if one of the variables is already isolated. So this was a really good example because I noticed neither of the x or the y was actually isolated here. So I actually took equation 1 because the coefficient is 1 in front of the x here. Okay, and I noticed that I could isolate for x right away. Okay, and I don't have to like divide or multiply in order to isolate for one of the variables. Okay, so it's actually more simple for me. Okay, make sure if you are isolating in equation 1, okay, you have to sub it into equation 2. Okay, so just like I said before, if you isolate for x or y in equation 2, you'd have to go back and you have to sub it back into equation 1. Okay, are there any questions here? So that was our final answer. The point of intersection was 1/2 and 9/4. And I also noticed, because I have fractions here, okay, the only time you would change the fraction to a decimal is actually if you're graphing out, okay, the system of equations. Okay, and that's why I see that the graphing method is not very accurate. Okay, and the reason for that is if you have decimals like this, like we got in this example here, okay, and if I graphed out the system of equations, I might not actually get an exact answer like this, okay? So I do have to do the algebraic method, okay? All right, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone in the next video. Thanks, bye.